Hi friends, and welcome to another installment of the Science of Music. Today we will dive further into understanding of frequencies so that you can act and understand the differences between pitch and frequencies. You know you have it when you can hear and graph the frequencies and pitches that you can see. Materials, you'll need your ruler paper from Monday's email, a paper, some pencil, or pen and pencil for our class activities. So let's get started. So today we have an awesome warm-up, and our question is, write down how the notes make you feel or what it makes you think of. So I'm going to play you a snippet of a song, and we are going to remember our definition of frequency, which is the speed of the vibration, and this determines the pitch of the sound. And it is useful, and it is only useful for musical sounds where there's a strong regular waveform. We're going to keep that in the back of our mind while I play this for you. So what we're going to be hearing is an audio recording of a word. You might hear the word Yanni, or you might hear the word Laurel. And then we are going to dive in to how you hear one or the other. But I would still also like you to write down how it makes you feel or what it makes you think of. So make sure you include if you hear Yanni or if you hear Laurel. Great job. So there is no right and there is no wrong answer. I heard Laurel, and that's just because of the way that my ear takes the vibrations of the air and understands them. If you heard Yanni, that means that your ear does it a little bit different than mine. But that's totally okay, because in our last set of videos, we found how the air molecules vibrate when they're really, really close to each other, and then how that vibration goes into our ear. But it doesn't all go into our ear the same way, because all of our ears are different, which means that we all perceive sound differently and we all hear differently. So frequency and pitch describe the same thing, but from different viewpoints. So frequency measures the cycle rate of the physical waveform. Pitch is how high or low it is when you hear it. And this relates to our Yanni and Laurel, because though the pitches were at the exact same height, because it wasn't like they said Yanni, Laurel. They were just saying Yanni, Laurel. They said it at the exact same pitch. It means that the frequency was different, and the way that the word was said, because of like the articulation and stuff, was different. And this relates back to the frequency of those two words. So think of the sound of a car or a motorcycle engine accelerating. As the engine turns faster at a higher frequency, the engine makes a higher pitch sound. So when I talk up here, I have a higher frequency because of the fact that I have a higher pitch. But when I talk like down here, or if I talk all the way down here, which is a little hard, I have a lower frequency as well as a lower pitch. So on our screen, we see a sound wave. Perfect. We can by now we should be able to tell me where the amplitude is, and the frequency, and if this is louder or quieter. But the human ear can only hear sounds within a certain range of frequencies, and as people grow older, their hearing range reduces. So a young person can usually hear between the ranges of 20 hertz to 20,000 hertz. So this would be this is for a young person. This would be like 20 hertz to 20,000 hertz. And we're going to listen to the differences in pitches. With the information you know and looking at our graph, you should be able to follow as our pitch changes and goes into different frequencies. At the lower end of this range are lower pitch sounds like the booming of thunder before a storm, and at the upper range are higher pitch sounds like the piercing whine of a mosquito. Between this is a whole sound spectrum of music. So some of these noises that we hear in our everyday life, we don't think of those as music. We don't think of car horns as music. We don't think of doors slamming as music. We don't think that birds singing is music. But all of those sounds for someone could be music. And you can't really think back to the first time you heard unless you had hearing loss. But what's really cool is you can still hear all of these sounds all the time. So you can't really remember the first thing you ever heard, but the first thing you heard when you woke up this morning, and you'll remember the first thing you heard before you went to sleep last night. But for some people, these sounds are music. And a door slamming could show anger, or it could show a lot of sadness, and birds singing could be someone's happy place, like in Snow White. When she would sing and the birds would sing back to her, that's someone's happy. So what we're going to do is we're going to watch a short clip from YouTube of the frequencies of 20 hertz to 20,000 hertz, and we're going to see how the sound changes. I would like you to record when you start hearing pitches and when you stop hearing pitches. And it's going to be different for everybody, and that's totally okay. So this is our video. It's 35 seconds, and it does have a warning to adjust your volume because it will get a little loud towards the end. So just be careful, especially if you're wearing headphones. Please be careful. So we are going to watch this one more time. And in the upper corner, I'll show you. In our upper corner, it does show the hertz as it progresses. It also shows decibels, and we will get into decibels next week. So please, you can watch this too, so you can see how not only does it move this way and how we have our sound wave down here at the bottom, but also as it changes up here. And if also, I don't know if you guys have experienced it the first time you listened to it, I know I did. Some places my hearing actually went in and out, so I could hear it some spots and I couldn't hear it others, but then I would get my hearing back. So if that happens to you, record that too. Great job, everyone. So make sure you send me how much you heard from where you started to hear, from where you couldn't hear anymore, which is totally okay. And try not to listen to this part of the video too much because you could get a really, really bad headache because of the frequencies being so high and low. So for homework tonight, I would like you to do this experiment. And it was sent in Monday's email So it says pitch and frequency worksheet. Hold the ruler tightly to the table and hit the other end. So when you're at school and you guys get rulers and then you hold it on the edge, if this is the table and you hold it on the edge of the table and then if you push it, it starts to vibrate and go like that. I want you guys to do that, and I would like you to see how the vibrations change when you give more when you have more of the ruler on the table or less of the ruler on the table. And you can use inches or centimeters to record that. And then when you're counting it, say 1 Mississippi, 2 Mississippi, 3 Mississippi for your seconds, and then try to draw it in our graph. So this is the distance from the ruler beyond the table, and then I'd like you to underline or highlight, if you did it in inches or centimeters, it's okay either way, and then how many Mississippis it took for the vibrations to stop. So once you hit it, it would be 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. And if you're in the middle of the word Mississippi, then you can count that as a half a second. And just make sure that you graph it on here and answer the questions at the bottom. If you have any questions on this activity, please let me know. My email is in the email link that was sent with the assignment. So I can't wait to see you guys' experiments, and I hope to see you guys on the next one.